Hello there, everybody. My name is Aaron. Thanks for joining me once again. I just wanted to record a quick video to show another issue that comes up during my work here. So right here, I've got a pantry cabinet that is configured the way that we like it to be. So we've got three drawer rollouts that are on the inside of the cabinet. One, two, three, four. And since this cabinet is so tall, we don't want it to wobble. We want it to be rigid. So we have a fixed shelf that is underneath the second rollout here. And if you look on the end view, you can see that the shelf is in line with the sorry, the hinges and the hinge plates of the door. So that's just the configuration that we have for our pantry cabinets. Not all of them, but for most of them, we try to have them the same way. So this works out well, just the way that it is. But I'll show you the problem that I have here. So if I change this to a pair of doors, because the door orientation changed, these hinges moved up. So there was what we call a parametric equation linking the location of these hinges and hinge plates to be centered with the location of the fixed shelf, wherever the fixed shelf will end up in the cabinet. But since I changed it to a pair of doors, it erased the parametric equation that was on the old door. So let me just go ahead and put it back, and then I can show you what I mean. But quickly here, let me just change this. So take a look over on this side. When I change this, the height of this opening here, I'll just go -2. There, you can see that the whole shelf moved up. So the shelves and the spaces are all linked together. But if I just equalize that back, there, it moved back down. But the hinge and hinge plates didn't move. So let me just quickly get my parametric equation sheet here. Which one is it again? Oh, here we go. Hinge to follow shelf. So the hinge plate. So these all mean something. It's kind of a lot to explain, but basically these equations, when we add them to a part, they just help reference the part that we're adding to another part. That's not really a good explanation, but here, let me just show you. So if I put that there, test it out. So basically, this equation is the cabinet interior, Fs is fixed shelf, the Y is the up and down position. That's the location, and it's referencing the cabinet interior fixed shelf thickness divided by 2. That centers the part to the fixed shelf. So if I press OK, that should, oops, if I can zoom in properly here, that should move, which it did. So that is equal to 0. So press escape and then put it on the other hinge plate. Okay, there, you see those moved. So now there's a separate one for the hinge. For some reason it doesn't like using the same equation, but let me just put that in here quickly, and then I'll move the whole assemblies up and down to just kind of show you how that all works. Oops. Okay, so there, we can see now that all of the hinges and hinge plates are centered in line with this fixed shelf. And if I zoom out a little bit here very carefully, if I were to move this, I'll go -5. So that will move up there. So all of the parts moved up, the fixed shelf, the hinges and the hinge plates, they all moved up and down together. So that is how the parametric equations work. So the parametric equation that I entered there, it centers the hinges and the hinge plates to wherever the fixed shelf location, uh, wherever we tell the fixed shelf location to be. So if I equalize that again, all the spaces in the cabinet are equalized and the hinges and hinge plates are in line. So that's kind of neat, I think. I'm pretty proud of myself for doing that one. But anyways, thanks for watching. We'll see you next time.